up for telling me how to multiply fractions. Madison.
So you just flip the 5 and the 8, like so.
I'm gonna come back to you because that's division. Okay. Isabel?
Cross canceling.
Okay, you can cancel. Always cancel. And you guys are gonna be even better at that this year. Remind me what canceling is?
Where you go from like the denominator of one to like the numerator of the other, and like you see if they can go into each other.
So go ahead and do it.
The 4 goes into 8 2 times.
And that becomes a 1, right?
Mm-hmm.
And?
Then 5 goes into 5 1 time.
Right, good job. So what's really going on here is you're thinking 4 divided by 4, 8 divided by 4. That's how the 1 and 2 come up. 5 divided by 5, 5 divided by 5, that's how the 1s come up, right? Then what, Isabel?
Then you multiply them, like, so you do 1 times 1 is 1, and then 1 times 2 is 2 times 1 is half.
Good job. Now, if for some reason somebody forgot to cancel, even though we're gonna be so good that we don't forget to cancel, what do you do in general, Mitchell?
You just multiply regularly, and then when you get your answer, you just.
Okay, so what would we get if we multiply regularly?
20 over 40.
That's easily recognizable that the zeros can go away and the 2 fourths reduces to a thing half, right? So we got the same answer, but this is the way I want you to do it. Now, you don't have to write all this stuff, okay? You don't even have to write the ones if something turns to a 1, right? Because it just kind of disappears in multiplication. Franco?
If you're not comfortable canceling, you still use the regular way.
That's a great question, but my response is you're gonna get comfortable with it. How do you get comfortable with it? You practice it, right? Remember was it you guys doing permutations? No, that's, you guys are like, what? Permutation? Permutations is a problem, Franco, that ends up, you don't write this down, ends up doing a problem like this. And if I would like do calculation, because I wasn't comfortable, instead of thinking, okay, wait, 5, 4, 2 goes into 6, 6 and 8 can both reduce by 2. And in here, I can say this answer is 9, 12 times 7 is 84. I can do that in my head, and it makes it so much easier than, for goodness sake, multiplying all of those, and then trying to get a common thing to divide them by. So my goal is to convince you how valuable canceling is, okay? Okay, so now if that problem was negative 4/5 times negative 5/8, it's the same problem, right? Negative times negative is positive. If instead it was negative 4/5 times 5/8, negative times positive is negative, but the process is the same, right? So,
what if it is not, and what if it can't cancel?
then you gotta multiply it.
Okay.
Yeah. Sure, it'd be nice if they always cancel, but of course they don't. Mitchell?
So you know how earlier you were saying like the -4, and then the negative was like by the 4 but not the 5? Like would they be the same?
What happened? Where'd it go? That one?
Yeah, that one. Like in the top right, are they all the same?
Those are all the same, yes. Oh, where'd it go? That's not the one that I did. Come on. I don't know what's going on. That's right. Okay, Addison,
Mhm.
3/4 divided by 1.5.
You multiply 2 by 1 and you add it to the 1.
Awesome, you have to make things mixed first.
And then you flip the 2 and the 3, so the 3 is on the bottom and the 2 is on the top.
And we change it to multiplication.
Oh yeah, you multiply it. And then it would be, then you cross out the 3, and then you cross out the 4 and the 2. And then for the 3s there's 1s, and then for the 4 there's a 2, and then for the 2 there's a 1.
Okay,
And then it equals 1/2.
awesome. Okay, so what she did, remember, 2 times 1 plus 1,
Oh,
remember that? Because what this is actually 2 2s. So 2 2s combined with another 1, 2, gives you
okay.
3.
But how do you get the? Oh, okay.
I'll do another one, Frank, when you do it for me. 4 and 3/5, what's that?
20 as the denominator and 7 as the denominator.
No. Denominator times whole number,
Yeah,
then add the top. So what's 5 times 4
20.
plus 3,
Oh, 23.
and that would be the top number.
Oh,
The denominator is,
it's so
yes. Cause remember what's going on, I'm gonna go back to this one now. If I have, I don't want that. If I have that 1, and then I join another one with it, this is 1, 1.5, right? But another way to say it is I have 3 halves. So that's what you're doing, every time you're doing this little shortcut, you're actually taking that whole number and you're dividing it into that size pieces. So that's why you're combining with the part that's left. Does that make sense? Okay. Alright, so if this was negative 3/4 divided by 1.5, it'd be negative 3/4 divided by 3/2. Negative 3/4 times 2/3. Yeah, mic drop. Okay. Bill,
I'm confused on
which part?
the negative. So,
Well, my point of the negatives is if I had a negative divided by a positive, dividing fractions, I'd still do what Addison spelled out for us, but the signs are different, so the answer is negative.
so
That's our
the top, if the first top number is negative, will the answer always come, like the top number?
Well,
always come
instead of thinking of these, and I'm talking to everybody, cause since this is about the 3rd time this is coming up here, don't think of these as separate numbers. This is a negative number divided by a positive number is a negative answer. Okay, don't get caught up in the little pieces of the fraction, cause it doesn't matter where the negative goes. We're looking at 2 numbers dividing, one of them's negative, so the answer's negative. Does that help, Phil? Okay. You guys are doing great remembering fractions. Any questions though, up to this point? Because some of you are very quiet. We'll find out. Come up. All right. Real quick, I'm not gonna work out all of these.
You want us to work these out on our paper?
No, just wait. Remember these old friends? Maybe they weren't friends.
Well, they were.
Yeah, cause right now, this is what I'm doing with sixth grade, so this is where you were last year, remembering how to do these these decimal problems. When do you need to line up decimal,
When you're
Mitchell?
When you're adding or subtracting.
So notice that, the bottom two don't have to be lined up. So for those of you who would do this problem and say 7.3 times 3.45, line them up and add a 0 and do all those extra rows of zeros, that is not necessary. Remember that. How about Franco's row, do the first one, Colin's row, do the subtraction one, Addison's row, do the multiplication one, and Lydia and Isabella do the division one. Okay? Not together, just, that's the problem you're doing. You don't remember? This is why we review.